Here we go. We have a question, lowest common ancestor of deepest leaves. We have given the root of a binary tree and we need to return the LCA, which means lowest common ancestor of its deepest leaves. So recall that the node of any binary tree is a leaf if and only if it has no children, and the depth of the root of the tree is 0 if the depth of any node is d, then the depth of each of its children is d plus 1. The LCA of a set S of nodes in the node A with the largest depth such that every node in S is in the subtree with the root A. Suppose we have given this example and we only provided the root. We need to figure out the lowest common, we need to figure out the deepest leaf, and after finding the deepest leaf we need to figure out its LCA. So in this graph the lowest, the deepest leaves is 7 and 4, and 7 and 4 LCA is 2 only. So the answer in this case is 2 node. So in the output it shows that 274, but we just need to return the node. The node in this case is 2. In the second example we have given only root, so we just need to return root. Then in the third example, so we have first 0, its left is 1, its right is 3, then 1 left is null, 1 right is 2. So the 2 is the deepest leaf, and we only need to return 2 node in this case. Now let's build the approach. So suppose we have given this example, and in this we need to figure out two things. First of all, the deepest leaf, and how do we calculate the deepest leaf? If the root is 0, then it's left or right 1 1. Then if any node is with depth d, then its left will be d plus 1 d plus 1, right? And its depth will be d plus 1 d plus 1. So we are sure that to calculate any node depth we need to take a variable, and we also need to figure out that node itself. So we need two things. First of all, the node, then its corresponding depth, right? So we need to figure out two things, and on any given node we will return that data. So we need a class. So a class name is data, and inside this we have two things. First of all, node and its corresponding depth, right? So on any given node we just need to return the data, and on a particular node, if the same depth node is coming from left side and same depth node is coming from right side, it means there's a deepest node on left side as well as on the right side. So this, that current node will be my LCA, right? But there may be a case that the deepest leaf is in the left side only and right side is not that deep. So we just need to return the left node, right? The left resultant that we are getting. Or let's take third example. In this, our right depth is more and our left depth is not more. So whatever node that we are getting from right hand side, we just need to return that, right? So let's calculate this. First I am on to this root node, then I will first go on the left side. So I am on node 5, I will go to its left side. So this is my current node. First I will reach 5, then I will reach 6, then on 6 if I go left, I will reach null node. So on the null, what we need to return? We need to return the data. What is the data? So data contains two things. First thing is node, the next thing is the depth. So if we reach any null node, so node will be null and depth will be 0 only, right? So from 6 left, we need to return null and 0. On 6th right, we will also return null and 0. right? So that's all. Then on sixth node, we are getting two things on the left hand side and on the data on the right hand side, and both depth is same. It means this is the LCA, so I will just return that current node is 6 and its corresponding data, corresponding depth. What is the depth? Depth is the, so the left depth is 0, right depth is 0 only, and if we include my current node, so the depth will be increased by 1, right? So we have the left side data. Now we go on the right side. So I will reach 2, on 2 I will reach 7, on 7 I will just reach null, so I will return null 0. On 7th right I will also return null 0. So here I am getting the same data, so I will just return 7, it means the current node, and the corresponding depth, which is 1. Same on the right side, I will just return 4 and 1, right? Then on this side, on value 2, the left depth is 1, the right depth is also 1. So we will just need to return that this is my LCA. The LCA will become 2, which is my current node, and depth is same on both sides, so I will just add one more depth. So 2 2 that we are getting. Then if we reach 5, left side we are getting 6 1, on the right side we are getting 2 2. So it means the right depth is much bigger, so I will just include the answer present on the right hand side. So I will just pick 2, and depth is increment anyways, so my depth will become 3, and that's all. And let's go on the right side. So I will reach 1, then I will reach 0. So from 0 I will return 0, which is my node, and the depth is 1. On 8 I will return 8 and 1. On 1 I will return my LCA is my current node, and depth is 1 2, right? Then on our root node, the deepest node is on the left hand side, right? So I will include the data, the node present on the left hand side. So I will pick 2 in this case, and depth is increment anyways, so I will just add 4, because the left side is much bigger, so I will pick both values, but for depth I will just increment one depth. Then I got 2 4, this is my resultant, but I don't need to return 2 4, I need to just return node, so I will just pick the first value, right? So that's how this will work. The main thing is to return a data that contain two things, node and depth. So let's code this. So we have a separate class data, and in this we have tree node and the corresponding depth. Let's make the constructor tree node depth. This dot node will become node, this dot depth will become my depth. Then just write a recursive solution. In the recursive solution, just return, just pass the root value. On this I am returning a data, and I am getting a parameter as node. So I will say this is my current node or tree node. So let's write current node. Okay, so the base case is if my current node is null, so I need to first create a data. On the data we have two things. First is node, the node is 0, node is null only, and depth is 0. I will also get the data on the left hand side, so left data is solve, and current node left. Also get the data from the right hand side, and we have a condition. If left data depth is much bigger than right data depth, so just include that node. So I will include the left node and left depth plus 1. Same applies on the right hand side. If right is bigger then pick right node and right depth plus 1. Otherwise, if depth is same on left side and right side, and this current node will become LCA. So I will include current node and depth is same, so I will pick the data on the depth on the left hand side and add plus 1, right? So let's run this and I hope it will work. So we have an error because if I'm calling this, I'm getting a data. So data contain two things, node and depth, but I'm only interested in node, so I will just get the node. And now let's run this, working fine. Let's submit this, and in between let's talk about time and space complexity. So in this, the time complexity is order of n because we are traversing a node only once. What about space? We are not utilizing any space, but we are using recursion, so recursion will take order of height space, right? And in the worst case it can go up to order of n if the height is also if the height is equal to the number of nodes. This is the only case if the binary tree is a skewed binary tree. And that's all. And let's wrap up this video. Code is provided in the description box. Thank you all for watching.